to day 19 of online instruction. I hope everybody is staying healthy and safe. Today we're going to talk about composite volume. Last class we talked about volume of familiar solids, which was shapes we knew formulas to. Composite volume has to do with finding the volume of shapes we don't directly know a formula to. So what we have to do is break it down into shapes we're familiar with. So the three shapes you see on this paper are examples of solids that we don't necessarily have a direct formula to solving, but we can break it apart into shapes that we already know. And that's how we're going to go about solving these. So to solve for composite volume, as I said before, we're going to break down the problem into familiar shapes. You're going to then solve for the volume of each. And then, depending on whether the shapes are connected to each other or they're one inside of another, we're going to either add or subtract to find that composite volume. So, we're going to look at example 1. We don't necessarily have a volume formula for that L shape we have here. So what we're going to do is break it down into the two shapes that we see. I see two rectangular prisms. I see prism A, which is a long rectangular prism, looks like a cereal box, and I'm going to put all the dimensions on it. So that bottom part there is 2 centimeters. That height we have 6 centimeters. And that width we have 3. So now that I have my figure alone, I'm going to find the volume of that. That's a rectangular prism. So our volume formula there is length times width times height. The length we see is 2, the width is 3, and the height is 6. So when we multiply all three of those together, we get 36, talking about centimeters, and volume is cubed. So that's our first piece. That's the volume of the first prism we see. Then we have this second guy over here. Let's change the color. Let's go with a purple. So we have like a flat cereal box over here. This is prism B. So in this prism, our length is 4, our width is 3 centimeters, and our height is 2. Again, our volume formula is length times width times height. Let's plug in. We have 4 times 3 times 2, which gives us 24 centimeters cubed. So we have the volume of one part, we have the volume of the other. To find the volume of that entire thing, what we're going to want to do is add them. So we have 36 plus 24 gives us a total of 60 centimeters, and volume is cubed. So that's how we find composite volume. It's going to seem a little challenging when you first look at the problem, but I need you to remember you're capable of solving for each bit, and then you can either add or subtract them. So taking it bit by bit, like any other math problem you've ever had. You look at it at once, you're going to get overwhelmed. So break it down. So for exercise 2, let's see what two figures I see. I see a cone. Make that a little neater. I see a cone here. And then I also see a cylinder at the bottom. So these are the two shapes I see. Let's go ahead and find the volume of that cone. So the cone, our volume formula, if you remember, it's pi r squared h divided by 3. The radius we see is 2, so let's plug in 2. squared times our height, which is 3, all over 3. When we multiply out the numerators, we get 2 squared is 4, times 3 is 12. So we have 12 pi over 3, which is 4 pi. I'm going to leave pi in my answer for now. It's going to get a little bit messy if I start putting it into decimals before then. Also, this question asks us to keep our answer in terms of pi. That means we actually never have to round it and actually multiply it by pi. We just keep that answer. We keep that pi in our answer. So the next thing we're going to do is talk about our second shape. And our second shape is a cylinder. So we have a cone and we have a cylinder. Volume of a cylinder is just pi r squared h. So the radius of that cylinder is the same thing as the radius of the cone. They share that side if you notice. So we have pi times our radius, which is 2, squared, times our height, which is 6. So we have pi, 2 squared is 4, times 6 is 24. So actually, let's just write it as 24 pi. So we have 4 pi and we have 24 pi. They're both centimeters. Oh, this is feet. All the mistakes today. Feet cubed. So when we add them, we have 24 pi plus 4 pi. It's going to give us 28 pi feet cubed. And that's our final answer. If we had to round to the nearest tenth, what we would do at this point is we would put in our calculator 28, the multiplication symbol, and pi. And then we would see what our answer is, round that to the nearest tenth. This last one is a little bit different because, unlike the other one, the shape is inside the other shape here. So we have to find the remaining volume of a cylinder if the height of the cylinder is 6 meters, the radius of the cylinder is 3 meters, and the ball has a diameter of 6 meters. So I want you to picture this right now as a cup of water, and you put a ball inside it, like a tennis ball. And we're looking for the volume of that water once that tennis ball is in there. So what we're going to have to do in this case, instead of adding the two together, is we're going to have to find that volume of the cup, find the volume of the ball, and then subtract them, because that volume of the water is going to be less if it's being taken up by that tennis ball. So let's see our two shapes here. Kind of gave it away. We have a cylinder on the outside and a sphere on the inside. Change up the colors. We'll do a green. I'm feeling green. Okay, so we're told the height of the cylinder is 6 meters. The radius of the cylinder is 3 meters, and the diameter is 6. But we don't really care about the diameter of the sphere because we know in the formula it counts the radius. Diameter is double the radius, or radius is half the diameter, so that radius is going to be 3. All right, so let's find the volume of that cylinder. All right, so the volume formula of a cylinder, as we said before, is pi r squared h. So we have pi times our radius of that cylinder is 3 squared times the height, which is 6. 3 squared is 9 times 6 is 54. So that's going to be 54 pi. So in this problem, they don't actually tell us if they want the answer in exact terms of pi or if they want a rounded answer, so I'm going to show you how to do both. Our units here are meters cubed, and I'm not going to turn this into a decimal yet because it gets a little messy if we turn to decimals a little too early. I suggest we wait till the end to turn this to a decimal. That way we can have our exact answer in terms of pi and just quickly turn that over. All right, let's go to a peach. So our second shape is a sphere. And the formula of a sphere we learned in our last lesson is 4 pi r cubed over 3. So all we really have to do is plug in that radius. The diameter is 6 again, so the radius is half of that, which is 3. Taking care of our numerator, 3 to the third power is 3 times 3 times 3, which is 27. Multiply that by 4, and we get 108 pi over 3. Oop. Going to the edge of the paper here. And then we divide 108 by 3 to get 36 pi. We're in meters cubed. Now to find that composite volume, we're going to want to subtract those guys. So we have 54 minus 36, which gets us 18 pi. Let's change the color for our answer. Go with the blue. So we have 18 pi meters cubed. This would be our exact answer. If we wanted to round this to the nearest tenth, what we would do is plug into our calculator 18 times pi and round it to the nearest tenth. That would give us 56.5, again, meters cubed. All right, and that is all for our lesson on composite volume. Remember, it's absolutely doable. Just remember, break it up piece by piece. If the figures are one inside of another, you're going to subtract. If they're next to each other, on top of each other, you're going to add them. All right, have a lovely day and enjoy.